All right, so I have separated the rest of the videos into the next types that we have, plus an application. So we're going to start with x-axis rotation and y equals, and then x-axis and x equals, and then we'll move on to y-axis rotation with y equals, and then y-axis with x equals. And all that happens is the formula itself changes, but it's a nice clean formula that's it's actually very easy to plug in and use. Where the complication comes is usually with the integrals, but I think we're okay there. All right, so with this one we already have y equals, and so when we take our derivative of it, y equals x cubed, we're going to get y prime, which is our dy dx, and that will give us 3x squared. So since we are using dy dx, that is the one we're going to be using for this one. So we need to find our ds off of that. We already have the dy dx. Next is just to square it. Okay, so now we're going to do y prime squared, which would be 3x, missed it, squared squared, which would be 9x to the fourth. And then next we add a 1 to it. So 1 plus y prime squared would be 1 plus 9x to the fourth. And then square root it, and now we have that part. And then we just attach a dx to it to make our ds. So ds equals square root 1 plus 9x to the fourth dx. Now we can plug it in. So s equals 2 pi, forgot the integral. It looks the same as my s. Let's make this an actual s. S equals the integral of 2 pi y ds. So we go to pi, and then our y is equal to x cubed. So again, we replace that with x cubed. And then our ds, we'll do in red, is the square root one. And there we go. There's our integral. Now we're going from 0 to 2 for our shape. Let's take a look at it to see if everything is good. So there is our x cubed curve right there from 0 to 2. So now when we rotate it, give it time, it's a little slow. It's got a lot of code going on. It makes this shape. So it's like one of those bull horns or a microphone from the 1920s or 1800s right there. And so you can see that's the surface area that we are creating here. All right, so now we just need to finish our integral. So if you notice, this is a nice clean u substitution because we have an x to the fourth, and with a u sub, we'll get x cubed. So we go u equals 1 plus 9x to the fourth, du equals 36x cubed dx. So the x cubed dx we'll leave alone because that's what we're trying to replace, and we'll move the 36 over. Okay, so now we can plug that back in. So we end up with, now it's not 0 to 2, so we'll leave that alone. I'm going to move the 2 pi outside. So the x cubed dx becomes 36 over du. So I'll put the 36 here. Du goes there. That's a lot of space. I don't need that much space. Du. And then all that we're left with now is the 1 plus 9x to the fourth, which is our u. So square root of u. So let's double check this. We did the 2 pi, it went here. The x cubed dx is 36 in du, perfect, and then that is square root of u. We got it all. Now we just need 0 to 2. Works exactly the same way. So if x equals 0, u equals 1 plus 9, 0 to the fourth, so that's 1. And then x equals 2, we get u equals 1 plus 9, 2 to the fourth, which is a big number. So let's check with our calculator. And so this becomes 145. So 16 times 9 plus 1 is 145. So we're going from 1 to 145. And I'm going to now just erase this because we're good at it and put u to the 1/2 so we can integrate this a lot nicer. So we have 2 pi over 36 times, and then this is going to be u to the 3/2, 2/3, 145, and 1. So now this becomes 1 over 18. So we end up with 2 pi times, actually there's a 2 and a 2, so that would become 9. So we get 1 over 27, pi over 27. So pi over 27, and then we're going to plug in the 145. minus 145 to the 1. And there's no way to break this one down. You could put it as a square root with a cube and then take out 145 and leave the other. So I'm going to just leave this the way it is. And then we can actually now check this with our calculator to make sure that it is correct. So we have our nice integral sitting here, and that's the one you should use, not this one. So we'll plug that in our calculator and make sure it's correct. And it's not. See, what happens is just like everything else, you're not thinking about what's going on, and I'm not thinking about what's going on. So you always need to verify these answers are correct. What was the second number I'm supposed to plug in? 1. And you can see I even put the 1 up there. It's 3/2. So you can see that one didn't work. So now if we go back up, hit enter, I don't have to even put in the exponent because it's a 1. You can see now it makes the exact answer. That is our correct answer. Always double check these. They're very simple errors to make in them, and you already have your integrals answer, so make sure you always double check them. But that's it. So you're just picking this one. So this one's dy dx because we have y equals. Next video we'll do x equals.